Okay, so technically, these examples we've covered already in chapter 7. They're leading us into the new content that we're going to study in chapter 8, which is solving more complicated trig equations. So these are trig equations that are pretty basic. There's very little steps involved, and we've already covered it. Careful things we have to pay attention to. Here, we're asked to solve for all angle measures between 0 and 360 degrees. All right, so previously we've solved these equations for all possible angles. So these are technically a little bit easier, but we haven't worked with them too much yet in the sense that we're looking for just the angles within 0 to 360. So I have a sine equation is equal to a positive 1/2 ratio. So remember, um, we have our little chart here. All students take calc, all sine, tangent, cosine. This is a positive ratio. Sine is positive in the first and second quadrants. Therefore, our angles must exist in the first and second because that's a 1/2 ratio. So I'm going to sketch two arbitrary angles, this green one in the first quadrant, this blue one in the second quadrant. Remember, your sine ratio measures the y coordinate on the unit circle, or y over r, right? So I'm recognizing this as a 1/2 ratio, which is going to indicate that we're dealing with a 30, 60, 90 triangle. And sine measures your y coordinate. So I'm going to move, label this vertical measurement as 1/2 unit above the x-axis. And then in this quadrant here, this blue ray is also going to be terminate 1/2 unit above the x-axis. That's going to give us a reference angle here in red of 30 degrees. Remember, 30 degrees is always the smallest angle is always opposite your shortest leg, where this long leg here is √3/2 from the 30, 60, 90 triangle. Not much to do here. The reference angle is also going to be the same as the measurement from standard position to the green ray, which is 30 degrees. This is one of our solutions. And then over here in the second quadrant, again, I have a 30-degree reference angle. And to obtain the angle rotation from standard position to the blue terminal ray here, I'm going to subtract that 30 degrees from 180 degrees and end up with my second solution of 150. And these are my two solutions for this example here. Question B is a little unique. Cosine theta equals 5. This is a conceptual level question. It's not much procedure involved. What you have to remember here is, if you use this unit circle as a visual, and the fact that the cosine function measures the x coordinate on the unit circle, or the x over r ratio, right? This is valued at 5, right? This ratio is valued at 5 here. But when you're looking at the unit circle, the furthest point the circle can get horizontally from the origin here is 1 unit, and the smallest point over here horizontally we can get is -1 unit, right? This is saying that it's 5, which is not possible because we can, our restriction here is from -1 to +1, and this is greater than +1, so this would be a no solution here. Secant, right? So most of the time we've dealt with this type of problem in the cosine function, but remember, secant is the reciprocal function for cosine. So in some cases, it's best to view this as, its equivalent in terms of cosine, which would be cosine theta equals +1/2, where secant is +2/1. Similar arguments to the previous question. This is positive. Cosine is positive in the first quadrant and the fourth quadrant here. Cosine measures your horizontal, so we're looking at horizontal measurements 1/2 unit to the right of the origin here. That would be this thick green measurement right here, 1/2. And then my vertical measurement would be the long side of the 30, 60, 90, which is √3/2, and then here, which would be √3/2, but negative because we're down here in the fourth quadrant. So at this point, I have my two quadrants. I have my two angles sketched in the respective quadrants, and I'm looking for the angle measure that produces a 1/2, right? So that would be a 60-degree angle measure from standard position right here. So my first angle in the first quadrant is 60 degrees. And then I have a fourth quadrant angle I need to find, has the same reference angle as the quadrant 1 angle. So this is a 60-degree angle as well. So to obtain the angle measured from standard position to the fourth quadrant terminal ray right here, I'm going to subtract 60 degrees from 360 and end up with 300 degrees. That's my second angle solution. Okay, over here, we're dealing with cotangent. Previously, we've dealt with tangent. Remember, cotangent and tangent are reciprocal functions. Cotangent ratio is x over y. The value on the right side of the equal sign here in the cotangent equation is a positive 1. So if that's the case and the ratio is x over y, then that means when we simplify this ratio to positive 1, the x and the y coordinate here must have the exact same value in order to simplify to 1. Therefore, that's going to indicate that there's only 1 point in the first quadrant, right? And that's because it's positive. Cotangent and tangent are positive in the first and positive in the third here. And there's only 1 point in the first quadrant that shares the same x and y coordinates. That's root 2 over 2, root 2 over 2, giving us 45 degree, 90 right triangle right here, right? So that's my reference angle, which is also one of my angle solutions for the first quadrant. So I'm going to identify that as 45 degrees here. And then down in the third quadrant, I have this green terminal ray, same argument. That coordinate point is negative root 2 over 2, negative root 2 over 2, because it's a 45, 45, 90 triangle as well. Reference angle is 45 degrees. Therefore, if I want to obtain the green angle rotation to the third quadrant here, what I have to do is I have to I have to add 45 degrees to 180 degrees. And that'll give me 225 degrees right here as my second angle solution. Remember, these trig equations, most of them are going to have two solutions. The exceptions would be when the terminal ray terminates on one of the axes, x or y. And in some cases, we have two solutions. And in other cases, we only have one.